Question number 61. The electronic configuration of pseudo-noble gas cations is. If we talk about first option, that is NS2NP6, this is the configuration of noble gas, not of pseudo-noble gas. If we talk about option 4, here is the correct configuration is given. That's N-1 S2, N-1 P6, N-1 D10 and NS0. This is pseudo-noble gas cations configuration, and that's why we'll choose it as the correct answer. After this, there's another question. Question number 62. Among the following, which is a wrong statement? In the given options, different statements are given, and in the statements, we have to choose the wrong statement. First statement is SH6 and pH5 do not exist. This statement is a correct statement because orbital overlapping is not possible in case of sulfur and hydrogen. Similarly for phosphorus and hydrogen also. Further. Now here is option 2. P-pi D-pi bonds are present in XeO4. This is the correct statement because that P-pi D-pi bonding is possible in case of XeO4. Xenon is there with its d orbital and oxygen is there with the p orbital. Further, third statement, number of 180 degree bond angles in XeF4 is 4. If we talk about this XeF4, it's a square planar molecule in this way. And there are 2 lone pairs in the p orbitals in this way. This is the shape of this XeF4. In this case, there are 2 180 degree bonds are present. So this statement is the wrong statement. Further, shape of I3 negative is linear. If I talk about I3 negative, the shape is linear in this way. I3 negative, and there are the lone pairs in this way. It is a linear molecule. It is a linear ion. That's why this statement is the correct statement. So which statement is wrong? The statement given here in option 3 is a wrong statement. After that, question number 63 we have. Question number 63, select the pair of species which are non-polar. To be non-polar, the net dipole moment or the mu value should be 0. Let's check the given options. First we have CO2. CO2 is a non-polar molecule because it's a linear molecule with effective dipole moment that's equal to 0. While in case of XeF3, it is not so. Mu value is not 0. It's a polar molecule. That's why it's not the correct answer. Further. Next one is XeF2 PCl5. If we talk about XeF2, in this case, there is the linear molecule. XeF2. Then the lone pairs. And overall, the net dipole moment for this molecule is 0 because this is a linear molecule. While in case of PCl5, this type of molecule is there. Chlorine atom in this way. Here the net value of mu is 0 because in this case the net dipole is cancelled out and ultimately mu value becomes 0. So in this case both the species given here are non-polar. Further, SO3 and XeF5. In case of SO3, this species has mu value 0. Non-polar species it is. But XeF5 positive is a polar species, that's why it's wrong statement. For the CH4 and H2O, CH4 is non-polar, but H2O is a bent molecule, we know that, and it is a polar species. That's why it's also wrong. So only one pair is there which contain both the species which are non-polar with mu value 0. And that's why the answer is 2. Then question number 64. 2 mole each of nitrogen gas and hydrogen gas were taken in closed vessel of 5 liter. If at 427 degrees Celsius gases were reacted and formed ammonia gas, then mole fraction of nitrogen and final total pressure of gases after completion of reaction respectively are. Consider ideal behavior of gases. We have nitrogen gas reacting with hydrogen gas to give you ammonia gas. And in the question it's given that 2 mole of each of nitrogen and hydrogen is given. If you look at this given reaction, you will identify that 1 mole of nitrogen is reacting with 3 mole of hydrogen and 2 mole of ammonia is produced. It means we have 2 mole of nitrogen, 2 mole of hydrogen also. And on that basis, this hydrogen would be the limiting reagent because its sufficient amount is not present. So it will decide the amount of product formed, as well as it will also decide the amount of nitrogen left in the vessel also after the reaction. So first we should know that you have 2 mole of hydrogen and 2 mole of nitrogen initially. So the consumed amount of hydrogen is 2 mole because it will be completely consumed during the course of reaction. While if we talk about nitrogen, its certain part is consumed. In this case, the part consumed of nitrogen is 2 by 3 because for 3 mole of hydrogen, 1 mole of nitrogen is required, and for 2 mole of hydrogen, there is the need of 2 by 3 mole of nitrogen. So the remaining moles of nitrogen on this basis is 2 minus 2 by 3, and that should be equal to 4 by 3 moles of nitrogen. Now what about the moles of ammonia after the reaction? Moles of ammonia are equal to 2 by 3 into 2, that's also equal to 4 by 3 mole. Now mole fraction of nitrogen that was asked in the question is equal to moles of nitrogen. What are these? The remaining moles of nitrogen is 4 by 3, and it should be divided by the total number of moles present in the solution. There are two gases present in the solution. One is nitrogen, other is the ammonia. The total moles of these two is 4 by 3 plus 4 by 3. That would becomes 8 by 3. It means this is equal to 0.5 mole. This is the mole fraction of nitrogen that is asked in the question. One more thing is asked in the question to find out the total pressure of the gases. It's written here. Final total pressure of the gases after completion of the reaction respectively are. That you need to just find out. So in this case, first part we have solved and second part is remaining. In this case, the total pressure that we need to find out using ideal gas equation, because hint is given that consider ideal behavior of gases. We know that PV is equals to nRT. And here we are considering the final pressure, final volume and final number of moles also. In this case, the final pressure that we need to find out. The final volume, in the question it's clearly given that vessel has the capacity that is 5 liter. That's why the final volume is 5 liter. N, the total number of moles which are present finally. So finally total number of moles are the moles of nitrogen plus moles of ammonia. It means 8 by 3 moles. What's the value of R? That is 0.0821. And what is the temperature there? The temperature is 427 degrees Celsius. In the Kelvin, this value becomes 700 Kelvin. Just multiply 700. And if you find out the final pressure, that would be equal to 8 by 3 into 0.0821 into 700 divided by 5. And on solving, this value comes out to be 30.65 atmosphere. It means both the values we have, one is 30.65 atmosphere, other is 0.5, that's the mole fraction. And on the basis of this, option 4 that we have here is the correct one. Question number 65. The reaction A is giving you B plus C, all are in gaseous state, has begun with 10 mole of A in 10 liter closed vessel. When equilibrium is reached, the concentration of C is 0.08 molar. The value of equilibrium constant Kc for this reaction is given by the expression. So first we need to check the reaction. A is there in the gaseous state, it's getting changed into 2B, and this B is also in gaseous state, plus C is in gaseous state. The reaction began with 10 mole of A in 10 liter vessel. So initially 10 moles are there of this A, and let's assume these two are 0. After certain time, X mole of C are formed, so definitely 2x mole of B would be formed, and A is 10 minus X. In the question, it's given that when equilibrium is reached, the concentration of C is 0.08 molar. It means the concentration of C at equilibrium. Equilibrium concentration of C is given. This was at equilibrium. Now, equilibrium concentration of C is given. So, it should be X, the amount, divided by the volume. And this is equal to 0.08 molar. And on the basis of this, we can conclude that the value of X is equals to 0.8. It means 0.8 mole of this C are present there. Further, there is the question to find out the Kc value. This Kc value would be equal to simply the concentration of B raised to the power 2, then molar concentration of C divided by the concentration of A. Active mass we are considering. The value of X we have. We can place the other values here. Concentration of B, 2 into 0.8 divided by 10 square into 0.8 divided by 10. Further, now the concentration of A, that is 10 minus X, and the X value is 0.8. So 10 minus 0.8 divided by 10, because the volume is 10 liter. And if you solve this for the value of Kc, there is the value that's equal to 0.16 square into 0.08, and it should be divided by 0.92. This is the Kc value. Where this value is, this is given here in option 2. On solving, you will find it. And correct answer is option 2.